Hi, my name's Cameron King, and I want to talk about computers. But not just any computer, I'm talking about quantum computers. So, what is a quantum computer? Well, by definition, a quantum computer is a computer that makes use of the quantum states of subatomic particles to store information. Now, that definition is a little bit confusing, so let's break it down. A subatomic particle is a particle that is smaller than an atom, like an electron. Particles at this scale behave differently than we would expect them to based on classical mechanics, which is the mechanics you learn in high school physics. One of the odd characteristics of these particles is something called a superposition. When a system is in superposition, it can hold two or more states at the same time. To quickly help visualize superposition, let's talk about Schrödinger's cat. Schrödinger's cat is a famous thought experiment that implies if you put a cat in a box with exactly a 50-50 chance of the cat dying due to a bomb, for example, before you open the box, the cat is both dead and alive before you can observe which one it is. It is in a superposition. But what does this have to do with computers? Well, a conventional computer stores its data in bits, which is short for a binary digit. A binary digit can either be 1 or 0. Each one of these values represents information. For example, the number 12 written out in binary is 1100. Quantum computers use qubits instead of bits to store information. A qubit can store the value of 0, 1, or both at the same time. Qubits take advantage of superposition in order to store data like this. So, how does this make a difference in the capabilities of a conventional computer versus a quantum computer? Imagine you're in a giant maze and you're trying to escape. In order to get out, you have to test each path individually, one at a time. That's how conventional computers work. But if you were a quantum computer, you would be able to test every possible path of exit at the exact same time. This is called quantum parallelism, and it is one of the many complex methods that quantum computers use to manipulate data. So, does this mean that all computers will be quantum computers in the future? Probably not. Conventional computers do just fine when it comes to everyday computations. However, when it comes to manipulating massive amounts of data, this is where quantum computers would reign supreme. Quantum computers would be able to simulate really complex systems with millions of variables. They could be able to predict the weather accurately, simulate high-energy subatomic collisions, and calculate pi to 1 trillion digits. A fully functioning quantum computer is still a ways off in the future, but the possibilities that it holds have scientists all over the world excited for what is to come. Thanks for watching!